Welcome everyone. In this GibbsCAM video, we're going to show you how to program a Swiss machine. In this case, it's a Tsugami SS26. You can see my part here. This is what we want to program. An SS26 is a 26 millimeter maximum diameter. And like I said, this is the part we're going to show you. If I look at my document control, you can see this screen is a little bit different than most MTM machines, standard turrets with sub spindle and main spindle. This, of course, is a sliding headstock type spindle. And you can see we have here a main spindle and a sub spindle. And of course, we're starting out with 1-inch material. And of course, you put in all your values just like you would on the standard MTM. Now, on this particular machine, if I show you the tool layout here, you can see the Tsugami SS26 has quite a few options for tools on the lower, upper, backside, drilling, milling. So a lot of different choices for the tools. So that's what we're going to be doing today. And like I said, I mentioned you put in your stock size, everything, your guide bushing, clearances, things like that on here. Now, as far as the tools go, if I show you the tools, this is a two-flow machine FANUC control. And you can see I have my tools separated into different categories here. Even though this is in position 1 or this is in position 8 or 10, you can still designate what tool is called up on the tooling inside the machine. So this doesn't necessarily correspond with the tools actually in the machine. So that way you can separate them into different categories. If I open up this one, for instance, this is a 150 thou drill, and of course it's pointing up, and you can see from the drop down menu you have a lot of different gangs and slides there. In this case, you have a gang front slide. You can see rear sides, etc. So I have all the tools that are going on the gang front in this list here from 1 to 8. You can see I have my end mills there, my grooving, my finish tool, my rough tool, and of course my part off tool. In the next section here, I have gang rear side, and here I have my drills, my tap, and threading tool. Next section, I have gang rear drilling for these two. Next section, I have gang front drilling. Next section, I have gang basic back drilling there. Next section, rear side back tools, and the last section is going to be back tool post. So I have all those lined up. Now, Swiss, it takes a while to set up a Swiss machine to put the tools in the gang holders, etc. So the best thing to do once you have everything set up, especially if you're not changing too often, you can save this list by just right-clicking. And again, with all GibbsCAM processes, you can save the selected tools to a tool list and give it a name, and then the next time you start a part, you can just load them in, and they'll be all in the correct places. So let's close that and close this. Now, as you can see, I brought my solid model in and positioned it so the front of the part is at Z0. If I bring up my coordinate systems, you can see there's the Z0 plane. And I also did a duplicate and translate so I can see it on my sub-spindle side. So basically I have it in two places, just like you would on most MTM machines that have a sub-spindle. We do about the same thing, so the Swiss isn't really any different as far as that goes. Now, I extracted the geometry. I made a few work groups here, but this one here, I extracted the geometry off the outer diameters. And that's, of course, easy to do. If I was to create, let's say, just a new work group, I could just click on this button here and click on this one here that says Slice Spun Body, and there's my geometry ready to go. Now, I could machine it right off this green geometry here, But I usually like to extract the geometry, so I usually click Extract Profile. Then I can turn off the profiler, and there's my geometry ready to go. So very easy to do. Just delete that. So let's get into our programming. So I have approximately 51 operations. And when you create the operations, the processes and operations in Gibbs, and you do a sort operations, Gibbs will put a space in between flow number 1 and flow number 2. So you can identify which tools, which operations go to which flow there. And since this is a 2-flow processor, you can go on the sync control and you can sync different operations so they're not cross-drilling, cross-milling while it's trying to turn, things like that. So you can do this here with all these operations, all these menus here to add a sync, remove a sync, and you also control which spindle has control over the movement, etc. So you have everything there you need to program the part. So let's go through our first operation. So basically we're just moving the tool group back to user location, some of these back to machine home. So that's going to be our very first operation. So that's just a utility operation there on Move Tool Group. If I click here, you can see a number of different utilities there. So that's going to be our first, basically our first operation. If I bring up the next one, I'm going to say this is machining mode, and it's going to be gang front machining. So that gets the machine ready for gang front machining. So my very first cutting operation is going to be to face this off. Of course, I have my geometry already, so I'm going to click on the face of the part there, face of the geometry, and give it where I want to start and where I want it to end, which is going to be right at that X0, Z0. And of course, Gibbs will bring it past there based on your tool nose radius. Second operation, or actually the fourth operation. This time we're going to do gang double drilling. So this double drilling, when I click on double drilling, it'll put the flow or the sync code in flow number 1. And if I scroll down here, you'll see it's also in flow number 2. So that way they can sync up flow 1 and flow 2 for simultaneous drilling. So then our next operation on spindle number 1 is going to be drilling. We're going to use tool number 10, 11, and 12, which is a 1/4 inch spot drill, then a drill, and number 22 is going to be our tap. So that's our first not our first operation, but the next operation in our list, and so we can just click on redo that. The next process is going to be sync control off. So we're done simultaneous drilling with flow 1 and flow 2 with the front and back. And then we just go through our part just as you would a normal lathe part or MTM. Of course, since this is a Swiss machine, you don't want to really machine back all the way here because of a very small part. Sometimes you do on Swiss machines, you'll get vibration, plus you only have so much travel on the guide bushing. So we're going to machine the first part of this, just this end here, as you can see. And just like you would on any turning, click on where you want to start, where you want to end, and click on Do It. So we have 3 operations there. Tool number 7, which is our roughing tool. Tool number 6, which is our finishing tool. And we're using 6 again to take a last little cut inside there. Next one, we want to thread. So if we bring up that operation, you can see that is using tool number 13, our threading tool. And you can see that the threading tool is facing down, so basically top down on here. So let's go through that. And again, then we're going to go to the next section of turning. Next, we're going to mill the flats there. Now you can either use the profiler like we have here, or you can actually extract the geometry from this edge here and create the toolpath there. And you can see we're on the YZ plane, and we want to duplicate that one time 180 degrees. So that's why it does it this way, this side and the other side there. Next, we're going through the turning again. This time we're starting here and ending just past this groove here. And we're roughing and finishing. And we just have material only on so it knows where material is left over from the previous tool. And number 6. Number 6 is our finish tool. So that's going to come in here and finish across here. And as you can see, it's not dipping down into the grooves there, any of them. And that's because we have this X minus turned off. If I had this on, you would see it would go down into the grooves. Okay, which we don't want. So we're going to just redo that. Then next, we're going to finish the grooves. Now I can just start basically anywhere on this line, finish on this line. And since we have material only on, Gibbs is not going to take the grooving tool and cut across these flats here because it already knows we've machined that from the previous operations. So if you look at here, this is a rapid move here, so it's above the part, so it's only cutting on the grooves itself. Next operation, we're going to finish this groove inside here. Then we're going to, of course, rough this and finish again. And then we're going to do some drilling. We're going to spot drill and then drill. You can see you can use the profiler to do this, so you don't actually have to extract geometry off here. You can click on the profiler and just click on the profile. You can drag this anywhere you want through the part. You don't want to be up here where it's basically a spline or an oval, so as long as you can get a circle there, just click do it and you're good to go. Of course, the depths will come from what you input here, not from this geometry that you clicked on there. So next, then we're going to take the basically tool number 15. Let me find that there, which is this one here. It's kind of a combination spot drill, chamfer tool, and we're cutting the flats, not really flats, but kind of the angles on here at the 45 degree. And again, if I go to the home view, and this we're using the profiler again this time, or you can extract the geometry either way, but this is the surface that I want to cut. And depending on if you want a climb wheel or conventional mill, then you can drag these in the direction you want to go. In this case, I'm going to climb wheel, so I'm going to start here, go to the opposite side in that direction. Of course, you'll see it doesn't have the 3 circles there to cut on the inside, center, or out because it already knows it's an outside profile there. So the only other thing you need to do is right-click here and say this is a single feature. So it only cuts across here instead of wanting to go clear around the part there. So next, then we do the opposite side, same thing. And then we're, of course, this time drilling the holes all the way through. Then as we go through this, we're basically doing the same thing 2 more times. So I'm just going to kind of walk through those kind of fast. There you can see you're doing the groove again. On this one, of course, this is kind of the last roughing and finishing. I want to start here and I want to go past the part because we're going to part off here. So I want to make sure it's past the part. Now if you want, you could put a point there if you want to snap to a specific location. You can also right click and say move the start end point by a certain amount there, so you could input the actual value there if you don't want to snap to a point. And that's we're drilling, still drilling on here, and of course finishing these 45 degrees, that side and that side, and finish drilling the holes through here. And of course the grooving, and then the last utility operation on flow number 1 is we're going to do a cutoff part transfer. You can see the Z clearance we have and how far we're gripping onto the part, 1 3/4 of an inch. So you can either alt click that, or if you know the value you want to put in there, you can input that already, just type that in. Now we're doing a C synced here, so anything on the back side of this part will be synced with everything else. In this case, the only thing on the back side are these flats, which will be synced with the holes. Of course, if you don't click on that, it can put this flat anywhere it wants to because you did not tell it to sync up. And if you actually want to shift the angle, you can do that as well by typing that in there. So then we go to flow number 2. So here is flow number 2. Now if you want to, if I click no zoom, you can see it fills both these up, and then you have to pan and zoom. So the best thing to do on something like that is go up to this part stations and turn off the main spindle. That way when you go no zoom, you can see it just fills up the sub spindle to your screen, to fit your screen. So I'm going to just right click and change to that coordinate system on the back side. So here is everything on the flow number 2, which is basically your back side. So again, this was on the first flow here, gang front machining. And again, we're facing off the back side, just like we did on the front side. And then of course we're drilling. You can see the tools we're using, 25, 24, 26. So if I scroll down to those, you can see there's 25, of course facing the direction of the sub spindle, 24, and of course 26. So all those are being done to the sub spindle, and of course we're using multiple process programming here. That way we can put all 3 of them together and click on do it one time. Our next operation, number 45, is M220 sync control off. So that is going to turn our sync control off, and then we're going to finish off the back side there. So this is our drilling. So this is tool number 29. As you can see, it's a 100 thou drill, pointing that direction, of course. And then we're going to rough this out, and of course take a finish pass. This is on tool 32, tool 33. So if you go down to there, you can see 32 is our standard roughing insert. 64 tool nose radius, you can see it's pointing this direction, and depending on if you do insert face up or face down, that will depend on if it's turning clockwise or counterclockwise. And of course 33 is our finish tool. And then we have, of course, the flats. If I go kind of to a side view, this time I used the geometry, so I just extracted the geometry off there. If I go to home view, you can see a little bit better there. And I said start right here and end over here. Of course, you can put points out here if you want to have it snap to exactly where you'd like, or right click and say move start point, end point, wherever you'd like. Of course, if you want a conventional mill or climb mill, that's totally up to you, either way you'd like to do it. And then another utility operation, we're going to unload the spindle into the parts catcher from the sub spindle, and you can put a Z position there depending on where your parts catcher is and how long your part is, where you need to place that before you eject the part. And of course, this is our cut part transfer. This is also from the flow number 1, as you can see. So these need to sync up with each other, both flows, so that does that automatically, puts that in there. So now if we do the rendering, we can see what it looks like. Let's turn on both the main spindle and sub spindle. We're going to show you a number of different views on here, but this is just the standard op sim. We're just showing you the part that's in the main spindle right now. So you can see the flats, of course doing the grooves, larger grooves, spot drill, 45 degree. And then of course we transfer to the sub spindle. Now if I go to my stops and say stop before part load and unload, let's get to that point again. So we'll rewind and go a little faster. And that's basically it before the sub spindle comes forward and we transfer to the sub. So this is what it looks like before we go to the sub spindle. So now we'll go over to the sub spindle and show you what that looks like. Now this is where our part is in the sub spindle, but it is going to come over here because in one section of this we're going to drill with the main spindle and sub spindle, so you'll see it kind of jump over there after it faces off, and then it's going to go back over to the tools on the sub side, so we'll zoom that up there, speed it up a little bit. Of course, roughing, finish, cut our flats, and there's our part on the sub spindle there. So that's our finished part there. Now it's a little bit easier using machine sim, so let's show you that. And here's the configuration of our machine. Here's all the tools I have. I put them in the specific places where they are on the machine. So you can kind of see, I don't need to see the inside of the machine, the actual sheet metal, things like that. So we just have our tools sitting where they need to be. So we'll show you the main spindle first. I'll rotate this so this is out of the way when you watch it. So if we rewind, and you can also just watch flow number 1 or flow number 2. We'll just stay with flow number 1. And here we're simultaneous drilling, and again roughing, finishing, threading, roughing again, finish, of course the flats, and again roughing and finishing, then grooving, larger groove, roughing, finishing, this time live tool drilling, cut across the 45 degrees there, come back and finish the holes, then again rough. Well, we already roughed and finished that, so we're just doing the grooves. The back part now we need to finish that by drilling and spot drilling and cutting the 45 degrees, finishing, and then of course the last grooves there. Sub spindle comes over, and as you can see we're in the midst of parting off. Click play, and it's in the sub spindle there, and back home on there. Now if I rewind and just show you on what the sub spindle is doing. Of course we're facing off up there, then it comes over, simultaneous drills. Then we're going back up to where it will be actually on the machine. A little bit better there. Okay, so now you can see we're drilling that long 100 thousandths drill pretty deep. Then of course with the backside tools, roughing, finishing, then cutting the flats. And we have our finished part. The only thing left is to eject the part, and we're done. So that's kind of a quick little demo on Swiss machining. A lot more tools to contend with, and of course every Swiss machine has a lot of options for additional tools, backside, front side, spindles, etc., parts catchers, angled heads, lots of different things. So anyway, this is a little quick little demo on Swiss machining. Very robust post processor for them. Takes a lot to sync everything up, but thank you for watching.